Hello, everyone. So we're about a minute ahead of the start time. Um, Usually, we use this time to let people just kind of trickle in and get situated before we start the workshop. And I also use this time to ask you to where you're from. There's my LinkedIn playing. Okay. All right. I see at least one person is here. Thomas, thank you for joining. Um, I see you're saying that Germans are always ahead of schedule in order to be on the safe side. That's great. That's a good attitude to take towards these things. I'm going to let this kind of play until about 9:01, 9:02, and then we'll get started. So I'm going to back off here. There we go. I see someone's here from Albuquerque, New Mexico. Good to see you again, Zach. Mm-hmm. Oh, we have someone here from Bangalore, India. That's also fun. So I'm getting notifications on my LinkedIn before I'm getting them here. Oh, someone from Seattle, Washington. LinkedIn user. I don't know what's going on with LinkedIn stuff, but sometimes they have like the LinkedIn user, and sometimes it says your name. So it's 9:01. So I'm gonna switch gears here. I'll talk briefly about what's going on in these current slides, and then we'll kind of get into the actual workshop. So as you can see, this current slide is about open source and AI jobs. So if you are looking for a job in open source or AI, scan this QR code. It'll take you to a form. You fill out the form, and you'll be in it's kind of like applying to a bunch of jobs at once. You'll be in a stack of resumes that I send out to a bunch of different companies. If you want the form link later, if you don't have time to scan the QR code, just ping me. This is me. You can find me on LinkedIn. I'm sure many of you have already found me on LinkedIn since this is on LinkedIn Live. This is the calendar. This calendar will take you to a list of events, online events, and in-person events. So if you're in Seattle or if you're in the Bay Area, we hold a lot of in-person events at least once a month in the Bay, twice a month in Seattle. And of course, this also takes you to the list of online events, including our next workshops, which will be multimodal RAG next week, and then agentic RAG the week after. And then this is Arise Observe. So Arise Observe will be happening on July 11th in 2024. I will be speaking at this conference. We will also be using Arise Phoenix, which is one of their open source libraries. We'll be using that for ways to improve our RAG applications today. And if you would like a promo code, there's a promo code there. OSS for AI will give you $200 off. If you are a VIP, or you think you are a VIP, which really, is totally up to you, feel free to send me a message, and I can get you a promo code for $300 off. But I only have a limited number of those, so it's kind of first come, first serve. All right, so let's skip out on this, and let's get into showing the actual slides. Okay, cool. So some more people have responded since I've been talking over those slides. Someone's from Texas, a couple of people from Seattle. Hello, Noel. Always good to see you. All right. Let's get into the improving RAG slides. Slideshow. All right. So during this presentation, please feel free to ask any questions that you have as they come up. So I have my LinkedIn open. So LinkedIn Live and StreamYard tend to have some sync issues sometimes, but I do have my LinkedIn open. So, feel free to ask. Oh, I muted myself. Whoops. Feel free to ask questions. I'll be checking my LinkedIn in between the slides, and we're going to get started. So we're talking about improving RAG today. So last week we talked about basic RAG. How do you build a basic RAG application? This week we're going to be talking about how you can make that application better. So in these slides, we're going to do a quick review of RAG. So those of you who were here last week, you'll kind of get a review, remember some of the things that we talked about. And then we're going to be talking about how you can make your RAG app better. And we're going to be looking at a hands-on workshop on how to make it better. So what is RAG? Remember, RAG is giving your LLM access to your data. That's all RAG really is. And this is the model of RAG that we went over last week. So just to give everyone a refresher, remember that you start with your data. You send your data to an embedding model. The embedding model embeds your data, turns it into vectors, sends that to a vector database. And then on top of that, you put an LLM, and that's how you get your basic RAG application. And when you go interact with that RAG application, you send it a query. You send a query to the LLM, and the LLM will take that query, embed that, or actually it will send it to the embedding model. The embedding model will embed that, and then it will send that embedding to the vector database, and the vector database will give you the most close responses, most semantically similar responses based on that embedding data, and send that to the LLM, which will then return it back to you. So the tech stack for this is some sort of LLM, which in this case we're going to be using Octo AI. So I sent out a post earlier to everybody who is signed up on Luma that you should go sign up for your Octo AI key on octoai.cloud. There's $10 of free credits for the first month. And actually, if you need more free credits, you can just message me and I can find a way to get you credits. I'm working with Octo AI to get people up to $50 of free credits. And then there's a vector search engine. That's the vector database. There's the embedding model, which is different from the LLM, but LLMs can also be embedding models. And then there's a framework that is optional that sits outside of it that makes things easier. And so just to cover some of these pieces before we get into everything else, remember that LLMs, this is the current state of LLMs, so to speak. Basically, last time we talked about how we went from basic neural networks to recurrent neural networks to transformers and to what is currently a decoder-only architecture, which is OpenAI's GPT. And the reason why LLMs are like this is because you need to keep track of the token, the current token that you're at, as well as the context. And so the way you do that is you do that with matrices and attention. In this case, self-attention. And basically what's going to happen is you're going to feed it the token input, some sort of sentence, and then it's going to give you some sort of output. And this is vector search, right? Vector search is just, when you take these vectors, you put them into an embedding model. And this is an embedding model, right? Just anything that turns words or images or whatever into numbers. Vector search takes these numbers and it kind of models these numbers and compares them. And the example that we're going to look at basically is that here you see houses, puppy, dog, and cat. You see that puppy and dog are very close because they're very similar. And cat is pretty close to dog, is also close to puppy. And they're all kind of far away from houses because houses and puppies and dogs, maybe puppies, dogs, and cats go into houses, but houses, puppies, dogs, cats, not very similar things. So that's how vector search works. It compares the semantic meaning behind these words and gives you some sort of distance. And the way you get those vectors is you use an embeddings model, which takes some sort of words. It doesn't always have to be words, but in our case today, it is going to be text. Next week, when we do multimodal, it's going to be images. And we're going to look at text and images. But it's going to take your text and it's going to turn into some sort of numbers. And for this workshop, or for last week's workshop, what we actually did was we used Octo AI for the LLM. We used Facebook AI similarity search for the vector search. We use Hugging Face for embeddings, and we use LangChain as our framework. So then our stack looked like this, where it's almost the exact same architecture that we saw last time. I've replaced vector database with face. I replaced the LLM with the Octo AI logo, and I've replaced the embedding model with the Hugging Face logo. And I've wrapped the LLM, the embedding model, and the vector database inside of LangChain. So I'm going to pause here briefly to see if there's any questions to address before we move on to the portion of how you can improve your RAG applications. Feed seems to be caught in a loop. Okay. Oh, okay. So you guys on LinkedIn, you're good. You're good now, right? Refreshing the page. Okay. So there doesn't seem to be any questions about this, what we covered last week. So I'm going to move on to the new stuff for this week. So today we're going to be building almost the exact same thing, but we're going to be adding an eval framework, and then we're going to be looking at how you can play with, and this isn't in the slides, I probably should have put this in the slides, how you can play with the chunking and the embedding model, as well as the metadata that you store, okay? So the one thing that we're adding this week, the new technology we're adding, everything else that we're touching this week is just going to be on playing with the code from last week and adjusting it and making it a little bit different. This is the only new thing we're adding, which is Arise Phoenix. So the way you can think about this is essentially you've got, you know, the architecture from last time, and I don't know why there's a box around this. There shouldn't be a box around that. It's just the logo. You've got the architecture from last time, and you've kind of wrapped the entire thing and put an eval framework over it. And so evals are a way to, I mean, as the name would suggest, to evaluate your LLM applications. And in this case, to evaluate your RAG applications. And so we're going to use Phoenix from Arise. This is an open source. Framework, and it's free to use. And I will show you how to download it later. Okay, and so let's cover some concepts before we get into the workshop. So the first concept I want to cover here is LLM. By the way, if you have any questions about these new concepts, please feel free to put them in the comments, and I'll address them at the end of the slide. So the first concept that we want to cover here is LLM as a judge. What this is really doing is this is using an LLM to evaluate the outputs of other LLMs. Now, this can be somewhat problematic when you're doing recursive evaluations. So I don't know if you guys really saw this on social media, or maybe it was just my friends who posted this, but there was a lot of buzz around using LLMs to judge the output of LLMs, and using the same LLMs to judge the output of other LLMs. So people would say you could use GPT-4 to judge the output of other LLMs, and it would say, hey, GPT-4 has the best output. You could use Claude to judge the output of LLMs, and it would say Claude is the best output. But of course, that's a recursive thing which has issues with it. And today, we're not going to face that issue because we're using Llama 3 as our model, as our LLM, and we're using GPT-4 as our judge. So we're not judging the output of different models. Well, we could. There are many outputs that you can use. There are many models you can use with Octo AI. Today, we're going to be using Llama 3. Actually, I will show you how you can change that model as well. And then we're going to be talking about relevance. So relevance is really about, is this output correct? Does this output make sense? Is it related to the input? How relevant is this output to the input of the RAG application? And then hallucinations. So I posted about this maybe last month, but RAG does not get rid of hallucinations. Now, hallucinations for LLMs are actually more common when you're not using something like RAG. Hallucinations for LLMs are more common when you have an LLM that has no context to be able to come up with an answer. And when you give it a context using your data, that LLM is less likely to hallucinate. So RAG makes your LLM less likely to hallucinate. It reduces the chances of hallucination, but it doesn't completely remove hallucination from LLMs. Now, the other thing to think about with this stuff is these are used for Q&A over what I would call more objective responses. And we'll get into this later on, actually. But subjective responses are not great to use evals on. So last week we had someone ask about what is the worst metro line in Paris or something like that. And that's actually not something that is really good to be using LLM as a judge or eval on in terms of evaluating the response, because that's a very subjective question and that's a very subjective answer. And now maybe you are, if you are in the audience today, you may be thinking to yourself, no, line 13 is clearly the worst in Paris. But LLMs, they don't know that, and they don't have that opinion in them. They haven't experienced metro lines in Paris. And so for foundational models, for AI, that kind of stuff is very subjective. And it's not good to use an evaluation framework to evaluate that sort of thing. Okay. So that's just one thing that I want to touch on in these concepts before we look to see if there's any questions. Would FACE handle large contexts and huge data sets? FACE, enterprise prod ready. So I assume that these are probably similar questions. So the thing that I actually think about with enterprise level production or handling context and huge data sets is FACE is actually implemented by all of the popular vector databases, right? So those of you who've known what I've been up to over the past year, I used to work at Zillis, and Milvus, the vector database from Zillis, actually implements FACE under the hood. Now, of course, it also implements other things. It implements things other than FACE, but it is used basically by every vector database. And in terms of enterprise readiness, it's not about really the algorithm or the engine or however you want to think about it that does the similarity search. It's not just about how FACE is an algorithm or an engine that does similarity search that talks about that is really what makes it enterprise ready. In a vector database, okay, so first of all, if you haven't heard me rant about this yet, vector databases are not real databases. Vector databases are a compute engine that sit on top of a storage. And so FACE is part of that compute engine. And enterprise readiness is not just about that, but also about the way that you route how the data goes in, right? So things that go into enterprise are like RBAC, role-based access control, concurrency, consistency, durability, availability, like these kinds of things. These are all DevOps things. So can you use FACE on large contexts and huge data sets? The answer is yes. Can you use it on a data set that is consistently updating? The answer is yes. Can you use it in enterprise? The answer is yes. Is it easy? The answer is no. Then you would have to do some DevOps work around some of this stuff. So in this example, we use FACE simply because FACE is used by everything. But if you want to think about enterprise readiness, you may want to look at the other vector databases. You may want to look at Zillis or Weaviate or Quadrant or Chroma or Pinecone or Mongo or Redis or any of these. Maybe not Mongo. I probably shouldn't say that. But anyway, you may want to look at some of these other enterprise kind of products, these vector databases that are out there. If you want something that is going to come with this durability and other things like that. I see you use, if you don't know the answer, just say you don't know in your prompt. Is this used to minimize hallucinations? Great question. The answer is yes, that is used to minimize hallucinations. Okay, so let's get into the code. You guys can see this? Yep. Okay. So let me. So if you have, if you followed along last time, the main thing that you're going to want to do this time is you're going to do pip install arise phoenix evals, and you're going to want to put quotes around it if you're working on the Mac, because that's just how Macs work. They're not going to, if you put the bracket there, it's going to mess with the bash or Z shell. And if you haven't, well, there is this line up here that shows you how to do all this stuff. And oh, you're also going to want to do, oh, did I not put this in here? Whoops. We're seeing live updates to the code. All right, so you're going to want to do that. And then you're probably actually also going to want, well, no, I don't think you'll need LangChain OpenAI. You'll probably need OpenAI though. So this here, you're probably also going to want an OpenAI API key equals sign environment OpenAI API key. Probably going to want an OpenAI API key for this, just because we're using GPT as our eval model. But that's going to be in the eval section, so you won't need it, but it would be helpful for looking at the actual evals. The main thing that you're actually going to want to look at here is going to come from this line right here. But okay, so let me actually, I'm getting ahead of myself. Let me walk through some of this stuff, and then we'll talk about this. Okay, so I'm going to make it bigger, and I'm going to zoom in. All right, everybody can see this. This is a good level of zoom for people. If anybody thinks this is a bad level of zoom, drop me a comment and I can zoom in more. I see no complaints, so I'm gonna keep going. Okay. So if you were here last time, you know about all these installs. I would consider really running this cell right now, because it takes a while to get these. And then I would also consider going to, let me post this into the comments here, to this website, octoai.cloud, to get your OctoAI API token. And for those of you on YouTube, you can see right here. That's going to be needed for the first block. But first, we're going to talk about this stuff. So LangChain, this is our framework, and this is the most popular LLM application framework to date. LangChain community. So LangChain grew and really kind of came to become very popular because of their community, because LangChain built such a thriving community. And they actually became so popular that they needed to create a second library just to have all their community integrations there. And so that's what LangChain community is. Face CPU. So this is Face. I'm running mine on my CPU. I'm on a Mac. I think this is actually slightly different for Windows. Last time someone had some questions about this. And sentence transformers. This is for Hugging Face. This is for the embedding model. This is OctoAI SDK. This is for OctoAI. This is for the LLM. Oh my God, what am I doing? LangChain text splitters here. This is for your text splitting. So we're going to be chunking up data, right? You don't want to take an entire document and just shove it into the database. So we're going to be chunking up data. And we're going to be using the text splitters to do that. And AlexML and tick token. So this is actually for HTML, I think, but or for XML type things, but we're going to use it. Tick token is a library that allows you to basically, it helps you chunk by looking at things as tokens. I heard someone pronounce this as TikTokin before. I think that just tells you about how popular TikTok is as a framework, or not as a framework, as an app now. Python.env is what I use to manage my environment variables. You can use something else. This is the new thing that we're installing, Arise Phoenix Eval. I Actually, is it eval or is it evals? What did I install earlier? Evals. So I messed this up. Arise Phoenix evals, and then OpenAI. Okay. So I'm going to restart this, and I'm going to hope that things work. Live demos are always wild. So, all right. Basically, we're going to load our environment variables here. All we're doing in this block is loading our environment variables, OctoAI API token, OctoAI OpenAI API key. And then we're going to launch Phoenix as basically this launches Phoenix into a web page. We're going to look at this later. This is going to give me a web page to go to, and I'll share my screen on this later, but I can only share one screen at once. So you're not going to see this right now. And then what we're going to do is we're going to make sure that we can actually use Phoenix with LangChain, because this helps you. This is how you can see Phoenix, but this is how you can make sure that all of your LangChain data goes through Phoenix. Next, we're going to ingest data. So to ingest data, we're going to import our text splitter and our document function. So here we're going to be basically taking this data. We're going to list this data here. So if you guys were here last time, you remember seeing this, remember hearing about this, right? So Houston, Karachi, Lisbon, Munich, whatever. All these cities are scraped from Wikipedia. And what we're going to do here is basically we're going to create a text splitter. So this is our chunker overlapper. So last time I told you guys we would talk more about this in this talk. So we are going to talk more about this now. So chunk size and chunk overlap are two different things that you use to dictate how long or how big how big your chunks are going to be. Chunks are just blocks of text. You can think about, I mean, like, I don't know how to make it more simple than that. It's a block of text, and you're going to look at your data to kind of determine what your chunking should look like, right? So here we can see that I want this to line wrap. How do I line wrap? Word wrap. Okay. So here we can see what this kind of looks like. This is like generally like one sentence or one paragraph, and you can kind of see this stuff. Maybe this is about, something like 500 characters, right? So 512 is the number of characters that goes into this, and overlap is like the number of characters that overlap. So maybe like this much is, actually I don't know, maybe like this much is like 64. But this is basically how I think about like small paragraph, sentence. That's basically kind of how I'd relate this stuff. And the reason why you want to have the chunk size is so you have something that's digestible for you and for the model. And the reason why, and also this has to do with context. So later on, we'll look at max tokens. And then you'll also want to look at chunk overlap, which is this helps you keep context between chunks. So one of the ways you can tune or improve your RAG application is by playing around with your chunk size and your chunk overlap. And when you do that, like if you take your chunk size and you make it, let's say 800, it doesn't have to be a power of 2. I just like powers of 2, but let's make it 800. Let's make it 808, like the drums. And you make your chunk overlap like 101 or something like that. It doesn't actually, this doesn't have to be the same. This doesn't have to be the same. What is it called? It doesn't have to divide cleanly into chunk size. It's just nice if it does. You can also make it like, I don't know, like 130. Okay, 1, 2, 3. Yeah, let's make it 1, 2, 3. And then make this 1, 2, 3, 4. That's fun. So you can do something like this. And when you do this, basically you're going to be splitting on 1,234 characters and 123 characters overlap. And so we'll look at character text splitter as well. So this thing, what this does is this splits on specific characters. And so in this case, the separator is /n/n. So this ensures that we split if we see a /n/n. And it also ensures that we are splitting on things that make sense. So I think, Okay, so here's the recursive character. Is that what we're using? I think we're just using the character text splitter. Okay, so we're using the character text splitter, which basically gives you a character that will split on. And you can also play with whether or not you're going to be using regex to do that or anything like that. In this case, we're just going to be using the default separator. And you can update this with any special characters that you want to split on. So for example, if in your text you have specific characters that indicate the end of a line or the end of a sentence or the end of what someone says, like that's where you would want to split on. Okay. And sometimes, you'll see that we have chunk size that are larger than the specified amount. And that's just because we want to make sure that we're not splitting in the middle of a sentence or a word. Okay, so let's go through all this stuff. So it should only take a few seconds to split. Where'd it go? Oh, here we go. Wow. Okay, so only a few were longer than 1234. That means that sentences or paragraphs essentially. And then what we're going to do here, we're going to import face from Hugging Face, and in the embeddings part. So in the embedding section, we're just going to use the Hugging Face embeddings. If you want to use different embeddings, what you can do is you can go to the Hugging Face website and get a specific embeddings model. So maybe you want, so the base model is this model. So I'm going to put this in the comments. The base model is this model. This is the default Hugging Face embeddings model. You can use other Hugging Face embeddings models, and that's basically what goes on here is you would give a name here and you would use something else. Remember that embeddings models, the thing they dictate is the size of your embeddings. And the important thing about embeddings models is when you are working in vertical specific use cases, then you want to use a specific embeddings model that has been trained on your embedding data. Okay, so that's what we're going to do here. We're getting the embeddings model, and then we're going to be, or your vertical specific data, sorry. And then we're going to put this into a vector database. So this take about 30 seconds. Someone asked, why not recursive text splitter as last time? I did not use the recursive text splitter as last time. You can use the recursive text splitter. In this case, the character text splitter works just as well for us. If you want, I think we can kind of maybe take a minute here and just go look at this a little bit deeper, right? So we've got the character text splitter. What this does is this makes a new text splitter and then checks the separator, checks the regex, and then has a split text function. If we use the recursive text splitter, it does something a little bit different. Splitting text by recursively looking at the characters. Recursively tries to split by different characters to find one that works. Splitting text that looks like characters. So the difference here is that the recursive text splitter will actually take a little bit longer. And the reason is because it's actually going to go look, and it's going to look at your separators. So this is, in some ways, you can think about this as a better text splitter, but maybe it'll take a little bit longer. And so what it's going to do is going to look at your separators like this, and it's going to work backwards, and it's going to try to make these separators a little bit better, checking if they're in regex or whatever. And then what it's actually going to do here is then it's going to split again. Oh, whoops. Yes. And then after it does a few different splits, it's going to take those splits and it's going to compare them a little bit. And then it's going to give you a final split based on the way that they're split based on these other text splitters here. So there's no like we can use recursive text splitter and it'll probably do the same thing for us. And I would suggest that if you want to try it, you can try it out. Okay, so, this was fast, 10 seconds. Okay, let's see, where are we? So now that we have all the embeddings ready, we're going to search the data. So I'm just loading things from Octo AI. I'm going to change this to 2048. Let's change this to 3000. Let's change this to 30. What's shit. 3072. Let's do 3072. So we need actually more max tokens than 1024 because our chunk size is 1234, so we probably want to have more. We probably want to be able to fit our entire chunks into our LLM. That's very important to be able to do. So we're going to do that. We're going to change this into 3,000 max tokens. And so I think Llama 3B goes up to 4K, if I'm not mistaken. It might be 8K, but I think it goes to 4096. So you want to, make sure that the model you're using has the number of max tokens that you need, and also that the way you chunk fits into the model that you're using. So the trade-off between this stuff is basically cost and speed. If you have a model that takes more tokens, it's going to be more expensive, and it's going to be slower, but it might be a little bit better. In this case, this is an example, right? We're not building a production application here, so we're just going to look at some examples. The other thing is you can actually use a fine-tuned model that's going to have more context windows. So I talked with Mark Wong from Gradient a while ago about extending the context window of Llama 3 to 1 million tokens. In that case, I think we'd have a really slow model, but it would probably be able to take a lot of context. Okay, so next what we're going to do is we're going to go and we're going to make a retriever. This is just LangChain's way of making vector retrievers. And so now we're going to give the LLM a prompt. You're a tour guide. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say that you don't know. Use 3 sentences maximum and keep the answer concise. Question, answer, context, blah, blah, blah. And now we're going to create a chain. So you can actually create custom chains. This is a custom chain through LangChain. But you can also create things like QA chains, which automatically creates something that does Q&A. And later on, we might be talking about things like how you can add memory and other things like that to LangChain. But this is just an example of one way that you can create a question, answer, chatbot, whatever with LangChain. So here, I've created this, this chain that basically takes the context from the retriever, takes the question, passes it to a prompt, passes it to an LLM, and takes the LLM output and puts it through a string output parser. And this was me playing around earlier. I said, name a landmark in Beijing. And so this is the audience portion, audience interactive portion of the workshop, basically. This is where you give me some questions that you want me to ask the LLM, and then we're going to run through maybe 5 of these questions, and then we're going to run through Phoenix, and we're going to see what Phoenix says about these, and we're going to get the evals, in place. So here it says the Great Wall of China. According to the retrieved context, the Great Wall of China is mentioned as a landmark in Beijing, specifically stating that it was built on et cetera, et cetera, et cetera. So this is a long context. You can see that this thing is a huge, it's like a really small slider. So there's a lot of words here. But let's see what other things, might be interesting to ask. Oh, someone's asking a question. If you're using an embedding model that's trained on your specific vertical, do you need an accompanying LLM for outputs that's also trained on your vertical, or can a general purpose model be used at that point? I would say you can just use a general purpose model. You don't need okay, so there's a lot of debate among this, and my personal opinion, my professional opinion is that it's much more effective to use the embeddings, because the embeddings model is kind of what you can think of as your preschool, elementary school, and then your LLM kind of stuff. You can think about this more like a college, like going to college. And I guess going to college is more about getting specialized. I don't know. Maybe you can think about, maybe that makes sense. I don't know. Maybe the LLM is your generalized stuff, and it's actually the basic trainings of the general school stuff, and then the embedding model gives you the context that you need to work in your professional field. So for example, if you are, I don't have the example ready to go here, but the example that I kind of think about with this is animals and cars. So, like Mustang, for example, is an animal, but it's also a car. And the way that you would be able to distinguish that is using the embeddings model, not the LLM. Same thing goes for Bronco, right? But Pony, for example, Pony is, most likely people, I don't know if Pony's a car. I don't think it's a car. Pony is like an animal, right? And Ferrari is a car. So that's the example that I kind of think about with this. And the embeddings model is what's going to determine how that word gets turned into numbers so that you can find the closest other words. No one has anything they want to ask the LLM. You guys just want me to make this up. There's no audience participation today. I'm just kidding. Obviously, there's some questions, but come on, guys. Last time someone wanted to know about the worst metro line in Paris. Does anybody want to know anything else about any of these cities? You're welcome, Jesse. I'm glad you asked. Come on, no one else wants to know anything? Name a landmark in Beijing. All right, fine. I can make some things up. Where should I visit in Seattle? No, that's a subjective thing. Let's see. What is an important historical monument in Seattle? Are there any important historical monuments? Probably. Oops. There's got to be the Space Needle. If it doesn't say the Space Needle, I'm going to say that this is wrong. If you don't know and your prompt is relevant to your RAG data or to LLMs in general, it is relevant to your RAG data primarily. Okay, so the way that the RAG to LLM thing kind of works is like you're going to be looking at, the Space Needle is an important historical monument in Seattle. Great. So the way that works is it's going to look at your RAG context first, and it's going to use that as the context, and then it's going to make something up because LLMs do this. It's going to make something up. Well, it has a chance. It won't necessarily do this, but it has a chance to make something up based on its data. And based on the way that your model is tuned, so your instruct tune models are going to be better at not doing this. It may or may not go to that data and say whether or not it knows. But it's primarily applied to your RAG data. And if your LLM and your guardrails are done correctly and your LLM is instruct tuned well, it's not going to go to the LLM data itself. Which city has the worst crime? I don't think this is going to know the answer to that because I didn't give it a way to link all this stuff. So next month, we're actually going to look at a way to link all of these cities together using a graph. What's favorite beach in Texas? That's a subjective question as well, but I can ask this. How about this? Name the top 3 rated beaches in Texas. Oops, I need to press shift. Galveston, South Padre Island, and Surfside Beach. All right. I don't know if that's true, but you person who asked this about Texas, feel free to let me know what you think about that. What is the best time to visit Orsay Museum? Oh, that's an interesting one. I think that's also subjective, but we can ask that. What is the best? I don't even know what Orsay Museum is. This is a long one. Maybe it's having trouble finding Orsay Museum. I don't know. Where is Orsay Museum? Where is this place? Wow, this is a really long one. Uh-oh, we might be running into an issue here. It's in Paris. Okay, so Alina is from Paris. I see. Okay. Oh, hey, here it is. Okay. The Orsay Museum is open from 9:30 a.m. to 6 p.m. Tuesday to Sunday. It's closed on Mondays. It is recommended to visit the museum early in the day to avoid the crowds. The context does not mention the Orsay Museum, so the answer is based on information about the museum. Okay, so this is from, so someone asked about, I think actually, Alina, you probably asked this question, was if you don't know, say you don't know. So this means that the model was trained on this information, but this information is not actually in the context. So what this tells us is that the model first looks at the context and then looks at the model information itself. Is temperature a parameter to keep the result of the LM focused? Temperature is a parameter to keep the LM from, let's say, being creative. So kind of, yes. What is the best way to travel in New York City during weekends and weekdays? I don't know if it's going to have this information. It might have something similar to the Orsay Museum, but let's see. Travel in NYC during the, let's just do weekdays. And let's see what it says. I don't know if I believe this. The best time to travel in NYC during the weekdays is during the morning rush hour or the evening rush hour. I don't know if I believe this at all. Oh, okay. It's saying many attractions and landmarks are open, making it a good time to visit if you're looking for a more relaxed atmosphere considering visiting the office off-peak hours. Okay, that makes sense. Okay, I guess this makes sense. I mean, you know, I guess I'd love to get your opinions on this as well and just see what you guys think about this. If the LLM doesn't have the data on what we asked, is do a web search to get the answer, or does it hallucinate? So here, I think you're kind of doing a little bit of a black and white thinking here. It's not necessarily hallucinating or doing a web search. So the LLM also has access to generalized data that it's trained on. And so I guess if you want to say that the LLM using its generalized data is hallucination, then it hallucinates. But I would say that this is just the LLM using the next step down. So if you think about the way that you can actually add web crawls to this, by the way, we haven't talked about how to do that. But the way, if you think about the way that the LLM works, someone asked constructive hallucination. What it does is it actually uses the context from the RAG as its main #1 priority of looking for information. And then it uses the information it's trained on to use to look for the next information. So if you think about that as hallucination, then every time you talk to an LLM, it's hallucinating, because that's what generative AI is. It's called generative AI. It's generating answers. It's hallucinating all the time. I think that's enough kind of answers to run the evals. So what we're going to do is we're going to run these evals here. And all we're doing here is running some hallucination evals, QA evals, relevance evals, whatever. So get QA with reference. This is basically a way to get all the QA stuff that we just run. And get retrieve documents gives Phoenix the access to the documents. And then we're just going to put it into the client that we just made earlier. And then we're going to run this. So this takes a while. So here we're using GPT-4 Turbo. You can use other models. I think you'd have to check out their other integrations to use some of their other models. Maybe next time we'll use another model. And then hallucination evaluator, QA evaluator, relevance evaluators. These are evaluators that are built into Phoenix that you can use to evaluate. And then this is basically like the answers, the hallucination and QA correctness. You run evals. So running evals is, once again, it's a function that's built into Phoenix. And it, gives, so data frame. So, this kind of shows you the background of these people who built Phoenix is a data science background. They're using pandas here. That's why they think data frame. And they turn their queries into a data frame. And actually, I'm going to show you the UI later, and it does kind of look like a data frame. So, you can think like, hey, these guys, they definitely use pandas. They're data scientists. These are the evaluators, right? So these are the evals that are, created. So the hallucination and QA eval with the eval model. And then, whether or not you provide an explanation. And then this is the relevance eval, which, runs the answers against the retrieved documents, right? So the documents are are from the vector database. These are the text that we vectorized and stored and then gets retrieved to answer the question. So the data frame comes from that. And then you're evaluating the relevance, and this says provide explanation equals true. I don't know of a reason why you would have provide explanation equals false, because like, why would you not want an explanation for how your evals are run? And then basically we're going to log all of these. So this is probably going to take a while. As you can see, it's not quite done yet. So we'll wait for this to finish up. And then once we finish up, we'll kind of go look at the responses. Does that mean the LLM has already been trained on a lot of data on the web, apart from what we feed here? Yes. So the LLM, I mean, LLMs are trained on all sorts of data. This is why there's so much like, maybe not buzz, maybe buzz isn't the right word. This is why there's so much like noise, talk, things being said about the ethicality, I guess, whether or not it's ethical for these companies to be training data on, training their LLMs on the web, and whether or not, the people on the web should be selling data. So a lot of this is your data. So like, yes, this generalized knowledge, like, where do these LLMs get this generalized knowledge? It's from people. It's from people updating the web. It's from people like you. So, it basically has access to the entirety of the web for the knowledge that it's been trained on. When asking a question that spans across documents, which city has the worst crime, wouldn't vector search pull the crime data from each city document as context? How does this work? So it probably would look at crime, but A, the Wikipedia documents don't have the crime data, and B, you would probably want to make sure that you can map the crime data to the cities. So in our case, we can do that because we have the city name as the metadata. But it probably would be better to have that mapped in another way, such as through some sort of graph or some sort of keyword table or something like that. So I guess the answer to your question is, would the vector search pull the crime data? The vector search would pull city and worst crime. So it might actually, well, you know what? Let's just ask the question. I don't think it's going to give us the right answer, but I think what the vector data is going to do is it's going to pull the worst crimes from different cities, or it's going to look for city and crime. And that may not give us a satisfactory answer. And this isn't going to be included in the evals because I ran this after the evals, but we can actually see what this pulls and just see what it says. It says, I don't know. Andre says, I don't know. Well, let's see. I don't know. This is taking a while. I'm assuming that because it's taking so long, what's going on is it's not finding the data, and it's probably going to try to find the web data from Llama 3. So if someone says it's a violation of privacy about the LLM data and how it's trained, yeah, I mean, it's, so here we go. Okay, the Tenderloin area in San Francisco has the highest crime rate in the city. The context provided does not mention the worst crime city, but rather the Tenderloin area in San Francisco having the highest crime rate. So there you go. Maybe San Francisco has the worst crime out of all these cities. I mean, I don't know, like Tenderloin, pretty sketchy area. Okay, so we've run all this code. Now we're going to go look at we're going to look at where it's open. Please tell me I have this open somewhere. Phoenix. Great. So here you can see that it didn't evaluate the last one because I didn't ask it to evaluate. It says, looking for the worst crime city, I don't know. So yes, there's a lot of I don't knows here. But here we can see that there's these hallucinations and QA correctness and stuff like that. So for example, this one says the Space Needle it's a hallucinated, oops, where is this? It's hallucinated, but it's correct. So this is interesting. The answer provided states that the Space Needle is an important historical monument in Seattle, which is a factual statement. However, the task requires verifying the answer based on the provided reference text. The reference text does not mention the Space Needle at all. Instead, it discusses other landmarks and historical aspects of Seattle. Therefore, the information about the Space Needle, while generally true, is not supported by the reference text provided for this task. Thus, the answer is considered a hallucination because it introduces information about the Space Needles that is not found in the reference text. But even though it hallucinated, it's correct. So this kind of gives you an idea into LLMs and like how weird they are right now. This one says this is incorrect. So let's see if this is actually incorrect because I don't know anything about this place. The query text asks for the best time to visit the Orsay Museum. The reference text does not provide the mention of the Orsay Museum at all. The answer provided gives specific visiting hours and a recommendation on when to visit to avoid crowds. Since there's no information about this, it can't be verified or supported. Therefore, it's a hallucination. So hallucinations, I guess the way that are classified in evals, hallucinations are basically anything that is not found in the reference data. So the question that was asked earlier about whether or not Llama 3 is hallucinating, or if it doesn't know the answer, if it's hallucinating or doing a web search, I guess the answer would be, in terms of eval speak, it would be hallucinating. The question, and then it also says this is incorrect. The question asks for the best time to visit the Orsay Museum. The answer provided gives the opening hours, and therefore it does not tell you the best times. So it's an incorrect answer. So this one is both not hallucinated and also correct. The query asks for a landmark in Beijing, and the reference text specifically mentions the Great Wall of China. And also, the question asks for a landmark in Beijing, and the Great Wall of China is a landmark in Beijing. So you can see that there's different answers that can kind of come up here. You can have hallucinated and incorrect, and hallucinated and correct, as well as not hallucinated and correct. So we didn't get to see one where it didn't hallucinate and was incorrect. I'm sure that will happen from time to time as well. Yeah, I don't have an example in which it does that. Okay, so that pretty much covers how to get the trace details. Sorry I missed this. Came to class late. Gosh, oversleeping. No, I'm just kidding. So here's how you get this. I will show you how to do this. Oh, I can show two screen. No, I had to stop the screen. Okay. So here, when we're doing this at the beginning, we launched Phoenix. And then we also launched the LangChain instrumenter.instrument for the Phoenix trace. And that's how we got the trace details. So that was the answer to this question. Can we see the prompt that was used to evaluate the hallucination or correctness? Yes, we can. I have to keep switching back and forth here. Oops, not this one. I believe. Where is it? Yep. Oh man, I knew where it was before. Uh-oh. Whoa, what the hell is going on here? Wow, I don't know what's going on here, but this, we can clearly see there's some weird hallucinations here. Okay, let's not look at that one. Let's see, maybe there's in here. Attributes, events, evals. Geez. Okay, so I don't know where it is. I definitely saw it before, and maybe it's here. If we can do this. Nope. Okay. Well, I can find this information for you, and I will send it out in the post event follow-up email, and I'll look for that information for you. But that's pretty much it. So, like I said before, for those of you who followed along, there is a way to get a certificate in this course, and this will also go out in the post-event email. Those of you who are on YouTube, I've sent this here. For those of you who are on LinkedIn, it's in the LinkedIn comments. And I will send this out post-event email as well. If you fill out this form, show us your GitHub. And what we'll do is, for everyone who responds to this and shows us that they've implemented this specific GitHub repo, you will get a certificate that is validated by OSS for AI. That's my company, as well as Octo AI and Arise. So yeah, fill out the form. You got a week to do it. Next week, we'll be sending out another form for the multimodal one. Last week, I did not have a form for the basic one. So unfortunately, we're going to miss that one. But for the improving RAG, you can get a certificate that says that you are, someone who knows how to work on RAG and improve RAG, and you've created this this application by filling out the form. So this will also go out in a post-event email with all these links. Please, fill it out. And if you have any questions for me, I think we've got 1 minute left here. We can take 1 or 2 questions. If not, I'm going to wrap this up, and I will see you guys next week. Okay, so we are at the top of the next hour. I do not see any new questions, so I will see you guys next week. And just feel free to respond to any of the emails that come from the Luma, from me, or whatever if you have any questions, or just comment in the comments. All right, see you, everyone.